So the next object on our list is what's called an ellipse. And you probably heard this word before, and the math term and the English term, they represent the same shape. An ellipse is kind of a flattened out circle, right? And the way we define this, an ellipse is the set of all points where the sum of the distances from two fixed points is a constant. So we're going to have these two fixed points. We're going to have all these other points around the edge here where this distance plus this distance is a constant. All right, these 2 points are the focal points. The line running through them is the major axis, right? The midpoint of the segment between the two focal points, it's just this midpoint here, that's the center. And the line that goes through the center and is perpendicular to the major axis is the minor axis. Okay, a lot going on, right? First thing we're going to do, we're going to derive the equation. And it's going to follow a process that's very similar to what we did with a parabola, but there's a few things you have to notice first. All right, so what I'm going to do, I'm going to put a focal point here, and we're going to call this distance C. All right, so this is the point C, comma 0, and there's a corresponding focal point on the other side. And I'm going to draw them so that the center is here at the origin. You notice this is the same trick we use with parabolas, right? With a parabola, we put the vertex at a place that was convenient. With the ellipse, I'm going to put the center at a place that's convenient. All right, so that makes this point minus C, comma 0. Then I'm going to put the vertex out here. The vertex is the far outer points, if you will, of the ellipse. So this is going to be, let's see, we're going to call this A, comma 0, and the corresponding point over here will be minus A, comma 0. Okay. Then there's another, we know it's going to have this elliptical shape, right? There's another point up here. That's kind of the farthest point out along the minor axis. I'm going to call this one 0, comma B. Right? So this distance here is B. Okay. First thing we need to figure out, what is that constant? Right? The definition says if you pick any point here on the ellipse, the distance to this focal point plus the distance to this focal point has to equal a constant. I need to know what it is. Right, and to see what it is, I'm going to remember the vertices are on the ellipse. They're the point where the major axis crosses the ellipse. So this point here is on the ellipse. Well, this distance from here to here, from this focus to the vertex, is A minus C. And the distance from the other focal point to the vertex, well, this distance from here to here is A, and this distance from here to here is C. So the whole distance is A plus C. And to find that constant, I just add those distances together. The distance from the right-hand focal point to my vertex is A minus C. The distance from the left-hand focal point to the vertex is A plus C. And if you add those together, the constant is 2A. Okay, hold on to that. We're going to need it. Okay, now there's one other number. Let me clean up just a little bit before we go in search of this. There's one other relationship that you need to see, because this is a formula we're going to need in a minute when we try to derive this thing. Let's say and look at this point here, right? The distance from here to here plus the distance from here to here has to equal 2a. That's a point on the ellipse. You take the distance from any point to each of the foci, plural of focus, add them together, it's 2a. So if I call this distance k, no, I already used k. If I call this distance d and this distance d, then d plus d is 2a, which means 2d is 2a. So d is equal to a. Excellent. So I'm going to actually just go ahead and replace it. I'm going to take these d's out and put a's in here. Okay, now the thing that really needs to stand out to you, all right? This here is a right triangle, which means a square, get them in the right order, which means this is my second key fact here. This is fact number 1. Fact number 2, b squared plus c squared equals a squared. Okay, hold on to those, right? We're going to need them. Okay, so now we can come up with the equation. And I'm just going to warn you up front, this is one of those things, it gets messy before it cleans up and turns into something nice, right? So I'm going to start with really the same basic diagram. I'm going to put my 2 focal points at c comma 0 and minus c comma 0. And I'm going to put my 2 vertices at a comma 0 and minus a comma 0. I'm going to put this other point, unfortunately this point doesn't have a name, this upper point on the minor axis, and we'll call it 0 comma b. Okay, so I'm going to do kind of like a lot like what we did using the distance formula when we found the equation of a parabola. I'm going to start by picking a point on the curve at random. Call it x comma y. Now, I know from the definition that the distance from that point to this focal point, okay, that's the square root of x minus c squared plus y minus 0 squared plus the distance to the other focal point. All right, that's plus the square root of x minus c, which is plus c squared, plus y minus 0 squared, equals that constant distance. You remember this was our fact number 1 from the previous slide. That distance is 2a. Okay. So first let's do a little cleanup. This is the square root of x minus c squared plus y squared plus the square root of x plus c squared plus y squared, and that equals 2a. Okay, you know how we solve radical equations, right? You get that have 2 radicals in them. We get one of them by itself and square both sides. Okay, so the first thing I'm going to do is I'm just going to take this second one, move it over to the other side. Right, this becomes the square root of x minus c squared plus y squared equals 2a minus the square root of x plus c squared plus y squared. Now I'm going to square both sides. Right, square this side. And I'm going to square the other side. And you remember, squaring both sides, that means multiply this side by itself. So I'm going to write it out that way. X plus c squared plus y squared. Okay, the left-hand side is the easy one. The squared and the square, they cancel each other out. This is x minus c squared plus y squared. Now on the right side, I've got to multiply these out. And look, writing that square root thing over and over again, it gets old fast. Okay, I'm going to abbreviate this. Okay, I'm going to replace this with I'm going to do the square root and a plus sign to remind me that that's the square root that has the x plus c. Because notice that's the only difference, right? One square root has an x plus c, the other has an x minus c. Okay, that's just going to make my life a little easier. So now let's multiply this out. We get 4a squared, right, minus 8a times the square root of the plus thing, minus, and now I've got this x plus c squared plus y squared, those square roots times themselves. So that's going to become plus x plus c squared plus y squared. Okay, now let's multiply out that right-hand parentheses. But before I do that, this should not be an 8 here. Sorry, correct this a little bit. That should just be a 4. I slipped an extra 2 in there somehow. Okay, now let's multiply stuff out. On the left side, let's do this one also. This is x squared minus 2xc plus c squared plus y squared equals 4a squared minus 4a times the square root with the plus expression plus x squared plus 2xc plus c squared plus y squared. Now, a lot of stuff is going to go away. There's an x squared on both sides. There's a c squared on both sides. And there's a y squared on both sides. Okay, so this got a whole lot nicer. Let's subtract 2xc from both sides. I'm trying to get that square root on the right side by itself. Right, so this becomes minus 4xc, and let's move the 4a squared over. Minus 4a squared equals minus 4a times that square root. Awesome. Okay, now things just cleaned up considerably. Now let's divide both sides by negative 4. xc, I'll make sure I don't lose something here. xc plus a squared equals a times the square root. Okay, now we do it again. Square both sides. Square this side and square this side. The left side becomes x squared c squared plus 2xc a squared plus a to the fourth equals a squared times, now I'm going to put it back, x plus c squared plus y squared. All right, so let's leave the left side alone. X squared c squared 2xc a squared a to the fourth equals a squared x squared plus 2xc plus c squared plus y squared. And let's move the a squared into the parentheses. X squared c squared plus 2xc a squared plus a to the fourth equals a squared x squared plus 2a squared xc plus a squared c squared plus a squared y squared. We're almost there. Okay, first, the x, c, a squareds cancel out. Okay, now let's move the a squared, y squared over. X squared, c squared minus a squared, y squared equals, let's see, move the a to the fourth over. A squared, c squared, keep track of what's left, minus a to the fourth. Whew. Okay, let's see. Now what? Believe it or not, we're almost there. This is a squared times c squared minus a squared. Okay, now, finally, fact number 2. Remember what fact number 2 was? Fact number 2 was a squared equals b squared plus c squared. That means if we move the a squared over and the b squared over, minus b squared is c squared minus a squared. Excellent. Let's write it that way. This is minus a squared b squared. Okay, now I did lose track of something. I lost track of this a squared x squared. So let's move that over to the left side, and I'm just going to squeeze it in here. Minus a squared x squared. Okay, let's factor over here as well. Factor an x squared out of here. This is x squared c squared minus a squared minus a squared y equals minus a squared b squared. Whew. Okay, replace that c squared minus a squared with minus b squared. And let's see, minus b squared x squared minus a squared, I lost my exponent there, y squared equals minus a squared b squared. Cancel out the minuses. Divide both sides. I'm going to have to go over to the right. Divide both sides by a squared b squared. B squared x squared over a squared b squared plus a squared y squared over a squared b squared equals a squared b squared over a squared b squared. The b squares cancel. All that's left is x squared over a squared. Over here, the a squareds cancel, and we're left with y squared over b squared, and the right side is 1. And that's it. Told you it was going to get nice. It did get nice at the end. That is our equation of an ellipse whose vertex is at the origin and whose semi-minor axis, that the semi-minor axis is half the minor axis and the semi-major axis is half the major axis, right? So this is an ellipse whose vertex is at the origin, whose semi-major axis has length A, and whose semi-minor axis has length B, right? And one caveat here, A has to be greater than B, right? And you can see that up here. If A is less than B, then C is going to be imaginary, and that's not what we're doing here, right? So A has to be greater than B, right? This summarizes everything we just did. The equation has center at the origin, focal points at minus C0 and C0, vertices at minus A0 and A0. This is the equation, and if we need to find C, we can use this formula. Okay. Now one twist. What if it's the other way around, right? So right now this number is going to be bigger than this number. What if it's the other way around, right? Well, that's all I did here, right? I switched these sides. So now the bigger number is under the y squared. When that happens, it just spins the ellipse, right? Remember how when we were talking about parabolas, right? Changing the x squared, changing the x getting the squared versus the y getting the squared, it changed the orientation from up, down to left, right. We've got the same kind of thing happening here. If the number under x squared is biggest, then what happens is you get an ellipse that looks like this. All right. On the other hand, if the number under the y squared is biggest, then you get an ellipse that looks like this, right? Just which way it's oriented. Okay, now that we've got the formula, right? Now that we've got the formula, in the next lecture, we're going to do the same process. We're going to look at how to take an equation and get these key elements, the focal point, the vertex, the center, etc. We're going to look at how to come up with the equation if you're given those elements, and then we're going to do some translations to see how we can get that center off of the origin.